Hey everybody, today we are coming in on day 3 of solving quadratic equations, but really we're still working with our second method. We're still factoring. So what I want to do is I want to take what we worked with last time, us using factoring as the dominant way that we solve quadratic equations, and I really just want to extend it. I would argue to you that if you are good to work through today's problems, then you are good to work through everything that we addressed on previous days. Okay, let's jump right in. What you see on the screen right now, I've got 4 quadratic equations. And so what I want you to do is I want you to use these 4 as a little bit of like a practice test, a little check-in. If you're comfortable to work through those 4 equations, then you have everything that you need from the last couple days. Okay, I want you to tackle them on your own. If you hit a snag at some point, maybe you struggle through A, then you work your way through along together with me, and we get that straightened out, then I want you to try to pause that video and give B, C, and D another shot. You try to make yourself as independent as possible in working through these 4. Okay? Get ready, jump in, and we'll see how well we do, okay? Pause the video now. Okay, we're back. So, if we take a peek, let's focus in on A. You are looking and you see that you have your variables, but you are unable to collect those into one variable term easily. So what we are going to do then is we're going to look to factor. Okay, 2 numbers that multiply to give 33 and add to give negative 8. Well, if I think 33, 11, and 3, then I could have a negative 11 and a positive 3, and those would collect to give me my negative 8. Now, the line that I really want to push on you to skip over today, to try to make instinct, is that blind red line that would then say, therefore, the first factor equals 0 or the second factor equals 0. I think we should be getting better now, and with a little practice on day 2 of this, to be able to view those factors as linear equations, and you isolate for the variable right off the bat. So we can view getting rid of that 11, or negative 11 I should say, so it becomes a positive 11, and view getting rid of the positive 3, so there's my negative 3. Okay, I would love it if all I saw was the gold solution. That's what we should be working towards. Okay, if we hit a snag on A, then you're pausing the video. If we end up hitting a snag on B, then you're pausing the video. Okay, we're trying to be as independent as we can be. Otherwise, we're coming along and we're going to take up all 4. So let's take a look at B then. I'm going to put a little wavy line down to keep them clear, but I'm going to keep all of the lines I need to see in gold. All the notation I need to see in gold. Okay, the first thing I notice, I cannot collect my variables into one variable term. But because everything isn't on one side of the equal sign, I need to make a decision. I notice that on the left side, I have my positive leading coefficient. So I am motivated then to get everything to the left side. That means I'm going to have a 3x squared, a minus 5x, a minus 2, and there is my equals 0. Everything is on one side, so now if I can factor, I'll have my product equal to 0. Okay, this one's going to take a little extra factoring just because it's a complex trinomial. So 2 numbers that multiply to give 3, 2 numbers that multiply to give 2. When I multiply across, I can get a negative 3 and a negative 2. That gives me a negative 5. But that's a problem. I need a negative 2, not a positive 2. So I'm going to flip it. And when I do that, I get a negative 6 and a positive 1. That can get me my 5. So I can now factor into a 3x plus 1 times an x minus 2. And same thing, we're going to try to skip that red line. Okay, I want you to watch a couple key things that we need to make sure we have down. Look on the right side, make sure you still have your equal 0. You cannot draw your next line's conclusion unless that states equals 0. Don't drop it off. That's going to drive you nuts. You're going to lose marks on that. So make sure that we still have our product equaling 0. I'm just going to get rid of that blue. The next part, make sure your next line starts with a therefore statement. There is no operation that takes you from this line to this line. None. Look back on the solution to A. There is no operation that takes you from here to here. It's a piece of theory that you're using. And anytime you use theory, not operations, we need to make sure that we explain that theory and we use it by using a therefore statement. So I take a peek then. I should be good to be able to state that the solution I get from the first factor equaling 0 should be negative 1/3. Get rid of the 1, divide out the 3. Or get rid of the 2. And there we go. Okay, if we came in on B, then I think we're doing well. Okay, same thing, pause it if you need to, otherwise we're working through C. Well, you take a look at C, and we notice we cannot collect our variables into one variable term. I take a peek, and I notice my coefficient on my x squared is positive on the right. So what I'm going to do then is I'm going to picture everything going to the right side. While I picture that then, and I'm just going to put that arrow up above, I am going to write everything down first. So I am picturing every term on the right side. I've got a positive 6x squared over there. To get rid of the negative 11x on the left side, I need to add 11x on the right. My negative 7 was already on the right. Everything is on one side, so it's equal to 0. If you are a left side only person, you may have moved everything to the left side, but then you would have found you had a negative coefficient on your x squared, so you should have divided everything by a negative 1 to change all the signs. Okay, we come in on something like C, numbers are getting a little bit bigger. That's okay because we're good at factoring. So I need two numbers that multiply to give 6 and two numbers that multiply to give 7. Well, if I go 1 and 7, I can already see when I multiply across, I'm going to get a 21 and then a 2. Those are too far apart to get me down to 11. So I'm hoping if we go 7 and 1, we can see we get a 14 and a 3. I need the 11 to be positive, so my 14 is positive, my 3 is negative. I can factor into a 3x plus 7 times a 2x minus 1. And now that I have that, I can draw my conclusion. If those two factors multiply together to give me a 0, then one of them must be 0. Get rid of your 7, divide out your 3. Or get rid of your 1, divide out your 2. And there we go. Okay, hopefully we're doing really well up to this point. And now I want to work my way through D. Two different ways to tackle D. And I am hoping that you took the most efficient route. You take a peek at D, and I hope that we notice your variable already is in one variable term. There's only one variable. So we did not have to go through and do what we may have done, which is get everything on one side of the equal sign and now look to factor. It's okay if you did. Hopefully we recognize we have two terms. There is no common factor, but there is a minus in between, so it's a difference. And when you recognize both of those squares as perfect squares, we could factor that as a difference of squares. We have our conjugates. If I then do that, I may be tempted to write down negative 3/2 or positive 3/2, but I don't like that form. Since I have the positive and the negative of the same value, please write that as plus or minus your 3/2. Okay, that would be what I would argue is we kind of had the blinders on. We weren't really looking. I would have loved it if you gave me the gold solution instead. So I'm going to put down an alternate solution. I would have loved it if instead you said you divided out your 4. Because your variable is in one variable term, just isolate it. Whether you want to show me this green line or not, I couldn't care. To get rid of the squared, you take the square root, and every time you take the square root, we have plus or minus. You could have skipped that line and come straight in on the plus or minus square root of the top, square root of the bottom. Okay, I'm going to leave those solutions up. I would love it if you had the gold. If you had the gold, then I think we're doing outstanding after day 1. Okay, that is our check for us, and that's what we've been working towards. How comfortable are we with what we've talked about previously? I mentioned to you at the beginning, if you were able to tackle some of the problems for today, then that almost removes that you needed anything from the previous day. We're building and building. Okay, we're really going to start to build and start to put together all your algebraic skills in one go. Okay, let's jump into another problem. I want you to take a look at E right now and take a moment to copy down E. As you're copying down E, we should notice that this one looks a little different than your previous equations. What you will notice is each individual term is not simplified. If you look back on all of the equations that we've worked with up to this point, you always had one squared term, one single x term, and a constant. Now, maybe one of those terms were missing, but you always had simplified terms. Now you take a look at equation E and you notice there's a lot of stuff that's unsimplified. That's your key to being able to solve E. If we can recognize that it's not simplified, then that should drive your strategy. Then what we should be looking to do is to simplify that. So what we can do is we can now spend a line, expanding some brackets, and collecting like terms in order to try to create an equation that we can solve. Okay, with that advice at the very beginning, I think you have enough at your disposal to go through and solve E. Okay, I want you to give it a shot on your own. Pause the video now. Okay, we're back. So I gave you some pretty good advice at the very beginning. That I will not give you moving forward. But I'm hoping that we can use that instinct to try to say, well, if I expanded on the left side and expanded on the right side, now what I'm creating are individual terms. Okay, I take a quick peek and I notice that I have some squared x's and some single x's. Maybe some stuff cancels out. Maybe I'm able to collect all that stuff into one variable term. I don't really know yet. So I don't think that there's anything wrong right now with us being motivated to try to put everything on one side of the equal sign. Let's start with our variables. If any one of our variable terms can cancel out or collect into one term, then we're going to want to isolate. Which means if we leave our constant till the end, then we always have the ability to isolate. We don't really have to backtrack. So I want you to take a look at that gold equation again and look at your 2x squared terms. Those are likely to be our leading term. So I really want to be focused on having a positive coefficient on those. Well, if I've got 3x squareds on one side and I've got an x squared on the other side, then the way I can put those together and ensure that I have a positive coefficient is to put everything on the left. So that's going to be my motivation then, to collect all of my variable terms on the left. Okay, here we go. So if I go through, well, then I have a 3x squared. I'm going to now subtract an x squared. So there's a 2x squared. I'm now going to collect my x's on that side. Well, I already have the -9 of them over there. I now need to get rid of this minus 2x, so I need to add 2x. Well, my -9x plus 2x gives me a -7x. And at that moment right there, where I see that I am not able to collect my variable terms into one term, now I'm motivated to say, okay, I'm going to finish by getting everything on that side. So I'm going to bring that 15 along. Well, to get rid of a plus 15, then I am going to minus 15. And there is my equation in standard form. Okay, I finally got my equal to 0. That's what I was looking for, because if I can turn that into a product now, I can solve. So I'm going to do that by factoring. 2 numbers will multiply to give 2. 2 numbers will multiply to give 15. Well, if I try 5 and 3, that gets me a 6 and a 5. I cannot get a 7 out of that. So if I flip it, now I can get a 10 and a 3. I can get a 7 out of that. I need it to be a -7. So there's my -10, my +3, and I do get a little confirmation again. Different signs. Negative. I know I've got a good fast factoring chart. So I can go through and now factor that into a 2x plus 3 times an x minus 5. And now that it's factored, I can solve. What makes the first factor equal to 0? Well, I need to get rid of my 3, divide out my 2. And the second factor equal to 0 is a 5. Beautiful. If you were able to get down to that gold, then that gives you some proof that you feel pretty solid solving a quadratic equation. Okay, that's what we're going to play around with for a lot of today. Do we have some unsimplified equations? Some of them are going to get big and ugly. This is going to evaluate, okay, are we good at being able to expand brackets, collect like terms, so simplify, and then factor to be able to solve? Okay, this is a real culminating activity today. Big picture stuff. Okay, let's jump into another one. Okay, they're getting a little uglier as we go, and I hope you can tell. Okay, I do not think you need any help from me at the very beginning. I want you to try to tackle F entirely on your own. As we work our way through, if you find you make a mechanical mistake somewhere or a strategy mistake, when it gets corrected, then pause the video and try to finish it off on your own. We really want to start to being able to work through solving these equations with little to no hesitation. Okay, it's your turn. Jump in and get going. Okay, pause the video now. Okay, we're back. So we take a peek. I notice that everything is unsimplified. I'm going to try to simplify it. So I'm going to go ahead and I'm going to expand my brackets. Well, I've got a perfect square on the left side, so I have to square the first term, multiply them together, and double it to get the middle term, square the last. On the right side, I just have to expand my binomials. I got a -2 of them, -1 of them is -3. Okay, take a quick peek and see, did you expand and collect well? Okay, I know that this might seem weird, but I am totally good. Me, having such a focus on efficiency, to say, spend one more line getting the green. Okay, I recognize that the only thing I was able to simplify on that line, collect on either side, was the 1 and the 3. But I think it's to your benefit to always simplify both sides of the equal sign before you start to try to isolate or move terms, however you want to think about it. I think it's worth it. I think that line costs you like, I don't know, 5 seconds, 10 seconds. I think it's well worth it as building up a pattern, a practice. Okay, now that I have that, now I want to focus. I can maybe collect my variables into one variable term. Maybe I'm going to get something that cancels out. Maybe I don't know yet, or I don't want to give it that thought. My focus then becomes, okay, get a positive leading coefficient. So if I see that I've got 4a squareds on one side and I got 1a squared on the other side, then the way that I know I can get a positive of them is to put everything on the left. So if I do that, then I'm going to have 3a squareds on the left. Okay, to get rid of my minus 3a, I need to add 3a. Well, negative 4 plus my 3 is a negative 1. And now that I see that I cannot collect those, I'm going to now bring that constant over. To get rid of a plus 2, I need to minus 2. And there is everything simplified on one side of the equal sign. Okay, now that it's simplified, I want to try to factor it because I've got an equals 0. And so if I take a line to say, two numbers will multiply to give 3, I think our instinct should be getting a lot better to write down 4 and 1. We see that a negative 4 and a positive 3 will get us to a negative 1. We get some confirmation that we are good. We can factor that into a 3a minus 4 times an a plus 1. And now that it's factored and equal to 0, therefore, get rid of your 4, divide out your 3, or get rid of your 1. Okay, I think you should include the gold. In fact, I need to see the gold. Well, I guess I don't really need to see the gold. I think it would be very possible for you to have started off with the original expression, the original equation, I should say, and jump to the green. But my advice to you would be, get the gold, include the green. It doesn't cost you much, and you can work through that equation pretty efficiently. Okay, I hope that we're doing well. As I said, we're going to keep going with this stuff. So I'm going to throw 2 more equations at you. Here we go. Okay, I want you to take a look at G and H, and I'd like you to work your way through both. Okay, pause the video now. Okay, we're back. So I'm hoping you're taking a look at G, and you were pretty quick. You might have even been looking at G going like, why is he bothering going through G? G seems like a step back from what we just did. And it is. I just want to draw to your attention, that right side is not equal to 0. So if I had anybody that said, hey, therefore k equals 8 or negative 1, we weren't paying close enough attention to the details. That right side is something other than 0, which means I got to expand my brackets on the left side. Okay, I expand, I get a k squared. I'm going to get a negative 7k as my middle term and my minus 8. Well, right off the bat, I should see that I can't collect my variables into one term. My leading coefficient is already positive, so everything's going to that left side. You should love getting a simple trinomial like that, because 2 numbers that multiply to give 12 and add to give negative 7 are negative 4 or negative 3. And therefore, your k value is 4 or 3. Nice. Okay, watch out for that. Don't see something factored and jump. Your focus has to be, do I have a product equal to 0? Okay. You take a look at H, and H was really the reason why I wanted to talk about both of these problems, or at least I guess it would be the main focus. We take a peek and we notice we have some fractions. And I'm hoping through last year and this year that we've built up some instinct that if you have fractions in an equation, you are motivated to get rid of them. Because it's an equation, then we have the disposal, or at our disposal, to be able to multiply every term, which means we can manipulate the way it looks. So when you take a look at H and you notice you have a divide by 3, a divide by 6, and a divide by x, we should be motivated to get rid of those divide bys. So, if you were to look at it, my advice to you would be put brackets around every single term. Here's a real common mistake. Look at the right side. I know it's 0. I know it's 0. But I want your focus to still be, we got to multiply every term by our value. Okay, what one expression can get rid of a divide by 3, a divide by 6, and a divide by x? Well, we may be going through saying, well, to get rid of a divide by 3, I'm going to multiply by 3. And then to get rid of a divide by 6, I'm going to multiply by 6. And then to get rid of a divide by x, I'm going to multiply by x. And you may have chosen 18x as your expression. I hope not. That will work. Yes, that 18x will eliminate everything. But as we've discussed a number of times, we want to get the smallest possible thing to multiply by. That way, maybe we can avoid having to do some reducing. So when you take a peek and you notice you have your divide by 3, so you need to times by 3, your divide by 6 times by 6, 6 already has a 3 in it. So we don't need to include another 3. All we need to include is that extra 2. So by choosing 6, we have already incorporated the other 3. We are good. Okay, so I need to multiply by a 6 to get rid of both of my constant denominators, and I need to multiply by an x to get rid of my divide by x. 6x is the best thing to multiply by. So I'm going to multiply every term by 6x. Yes, even the right side. And that's going to eliminate all my divide bys. So let's very quickly go through and let's eliminate them. Well, a 6 divided by a 3 is a 2. A 6 divided by a 6 is a 1. An x divided by an x eliminates that. And then on the right side, I got 0 times anything. Well, then there's my 0. Okay, what we see in gold, there is my simplify. So let's go ahead and simplify. My first term is now a 2x times x. So that is a 2x squared. My middle term is now a minus x times 1. So a negative x. My last term is a minus 6 times 1, a negative 6. And on the right side, 0 times 6x, 0. Okay, I am hoping that you would be motivated that if you see fractions in your equation, your first job is to eliminate those fractions. We get a little extra in equation H because we had a denominator that had a variable in it. That's something that we're not overly used to. But you notice your outcome gets you right back to something we should be comfortable with. I can't collect my variables into one variable term, so I'm going to go ahead, get everything on one side, and look to factor. Two numbers multiply to give 2. I already know that that cannot be possible. I do not have a common factor in my expression, so I cannot have a common factor across in my fast factoring chart. Oops. So I know as soon as I wrote that 2 and 1 that 3 and 2 would be my only way to organize those choices of factors. And I really like it. It works because there's a negative 4 and a positive 3. There's my negative 1. So I've got a 2x plus 3 and an x minus 2. And therefore, x equals get rid of the 3, divide out the 2, or get rid of the 2. Okay, hopefully we matched up. And I think if you can take a quick look back, all the previous equations, even going back to the very beginning for today, that this should give you a good breadth, a nice span of quadratic equations that you should be comfortable with. Okay, if we are good up to that point, then I want to change gears a little bit. Let's move away from some mechanics and let's tackle a little bit of problem solving. Now, okay, I want you to take a look on the screen right now. Hopefully you've had a chance to give it a read. And you see that your instruction, write a quadratic equation whose roots are, and let's just focus in on problem A. Okay, we need to write a quadratic equation whose roots are 4 and -6. Okay, I want to talk about a couple things with the problem. But I also want you to get a chance at some problem-solving experience. So I want you to tackle A. Do not tackle B. Let's come back for a second, have a little chat, make sure we're good on some theory. But I want you to try A on your own. Let's deal with this as pure problem-solving practice. No discussion. Can you figure your way through A? Okay, try it on your own. Pause the video now. Okay, we're back. So if you gave A a shot and you were able to try something, great. I don't even care what you tried. Great. Okay, let's clean up on a little bit of theory. First off, the question says write a quadratic equation. I want us to be very particular about our wording. I want you to notice that that problem did not say write the quadratic equation. Had it said write the quadratic equation, that implies there is one answer. There is only one quadratic equation whose roots are that. But if it says write a quadratic equation, well then that implies there are multiple answers. And yes, in fact, we have infinitely many answers. So if at the very beginning of your problem, you had some hesitation because you kind of felt like, yeah, but like I've got options, then that was a good instinct. That was a really good instinct. The second part, let's highlight the word roots. We reviewed what roots means. We should be quite comfortable with the word roots. But let's just recall that when we talk about roots, really what we're talking about is the solution to an equation. So if I asked you, problem 2, in different language, I could have said, write a quadratic equation whose solutions are 4 and -6. And maybe that helps a little bit. Okay, for anybody that was stumped and now they've got some guidance, I want you to try the problem on your own. Okay, pause the video now. Okay, we're going to work our way through now. Assume that we understand what the question's asking. Let's go through and try to build. So what I'm going to do is I'm actually going to write down some stuff that I would not have to see, but it's going to be extremely useful for these problems. If I recognize that roots are solutions, then really what I might have had was x equals 4 has to be an answer to the problem, and x equals -6 has to be an answer to the problem. That's me interpreting the roots word, the answer to the equation. Okay, well, if those are my answers, then maybe I could work backwards to figure out where they came from. Like that is, we've just spent a day and a half, almost 2 days, solving quadratic equations, solving equations that gave us multiple answers, and we did it by factoring. We did it by having things equal to 0. So if I took my blue and I said, okay, what if I wanted that equation equal to 0? And what if I wanted that equation equal to 0? Then really what I could think of a little bit, if I took my blue, is let's get rid of the 4, let's get rid of that -6, let's get everything on one side of the equal sign. Because what I now have in green is an x minus 4 equals 0. I have a 0 solution. That's really what roots means. Okay, well, where could that green have come from? Well, maybe if I put those back together, if I had a factor of x minus 4 times a factor of x plus 6, and I knew that those two factors multiplied to give 0, then one of their factors has to equal 0. Hey, this is like me solving a quadratic equation, but backwards. Okay, if I gave you the instruction to that problem, write a quadratic equation whose roots are that, then you are done with that line I just started. You're done. That is a quadratic equation. And the roots to that equation, the solutions to that equation, are 4 and negative 6. Okay. Can we maybe see where we get infinitely many options? Like, in fact, I could have had some of you that would have said, ooh, I don't like the look of that. So my instincts kick in, and I just go through and I expand those brackets and collect like terms. Well, you just gave me a different looking quadratic equation. Just as good. That starred line is another quadratic equation. Okay, now I need to talk about some detail. And to do that, I'm going to get rid of that other star, and I'm going to put a different color beside it. I'm going to put that one as a blue star. Okay, I'm going to get rid of that blue star, and I'm going to call that a red star. If I look back in the problem, and the problem says, write a quadratic equation whose roots are, then you are totally good to give me the gold star. But if I change the question and I add in a phrase, then I can make it where you cannot give me the gold star, you have to give me the red. If I changed my question and right up in there I said, comma, in standard form, comma, now I need the red. I need it. Standard form's going to tell me I've got to expand any brackets, I got to collect like terms, and I got to put everything in descending order on one side of the equal sign. Now the red is mandatory. Without that red, your gold is good. Okay, I'm hoping that we had some good instinct on that problem and that you feel kind of comfortable just picking your way through and stumbling a little bit. Okay, what I want to do now is I want to give you a shot on B. Okay, I think we have a roadmap on A if need be. I want you to go ahead and tackle B. Okay, pause the video now. Okay, we are back. So, if I was to work my way through B, then I could do the exact same thing we did on A. Like, I could sit there and I could say, well, if that's one of my solutions and that's one of my solutions, I can state them then as a x equals and x equals. Now, one of the lines that I do not like is this. You could jump straight from there and go straight to a green and say, well, then x plus 2/3 times x minus 8/5. That product equals 0. And I'll be honest with you, I don't like that one that much. Like, it completely satisfies what the problem asks. Completely satisfies it. But I don't know why you'd want to go through and introduce fractions. That would never want to be an equation, or that would never be an equation you would want to work with. So, my advice to you is, don't get to that point. However, if it said the problem asked, write a quadratic equation whose roots are, then the green is fine. If, though, I tack in that red in standard form, then you do not like that green, and I'm going to bet and say you absolutely would not want to expand those brackets. So, my advice, work with the blue a little more. Get rid of your fractions. So, to get rid of a divide by 3, you're going to multiply by 3. Now, get that equal to 0. Notice all your fractions are gone. You have a better factor to work with. Okay, I'm hoping we can actually jump a step with the other one. that we would be good to multiply out my 5 and get my 8 over there. Now I have that factor equal to 0. That I think for everybody, they would prefer to see 3x plus 2 times 5x minus 8 as the form of their quadratic equation to work with. And if I tacked in that red statement in standard form, well now, expanding those brackets, minus 24 of them plus 10 of them, is so much easier to work with that I don't think that one becomes a problem at all. Okay, we had a little bit of problem solving on that one. Us working backwards. I gave you the solutions to an equation. Could you go backwards and build the equation that would give it? Okay, great experience. Okay, I want to tackle one more problem. Okay, I want you to give problem 3 a shot. So take a moment, copy it down, and then I want you to work your way through 3. We'll go pure problem solving again. Okay? You jump in, give a solution, pause the video now. Okay, we're back. So what I want to do is I want to deal with this problem 2 different ways. And in fact, I'm going to kind of deal with them in opposite directions. I want you to be able to see that there is no one way to solve this problem. It really just depends on where do you want to put your focus. So I'm going to shrink this down a little bit so we can work through 3. For the equation, so it gives me a quadratic equation there, if one root is negative 5, so it gave us one of the answers, then I have to find the value of k and the other root. Okay, so what if I start working my way through on that with a particular focus? And maybe that focus is, well, it asked me to find the value of k, so I'm going to find k first. Maybe that became my focus. Well, what I should know then is since it gave me one of my roots, 5. 5 was one of the answers I got. Then I know for that statement, x has to equal 5 to make that equation true. So maybe all I do then is I say, well then I'm going to sub in an x value of 5. I know it makes it true. And when I do sub in that x value of 5, I'm going to get 5 squared plus k times 5, so 5k, plus 40 equals 0. And look at what I just built. I've got an equation. And in fact, it's a linear equation. Look, my variable has an exponent of 1 and it's only in one term. So I could go ahead and isolate that pretty quickly. I notice on the left side, my 2 constants are going to come together to give me 65. So to get rid of that, I need to minus 65. I can then divide out my 5. 65 divided by 5 is 13, so there's a negative 13. Okay, I just did what one of the problems, or what the problem asked me to do, which was find k. So notice, that became my motivation. Let's find that first. Okay, well, if I found k, then I now know what that missing value was. K squared minus 13x plus 40 equals 0. I could just go ahead and sub my k value back into my equation. And by doing that, I could now solve my equation to find the other root. So I could go ahead and factor it. Hey, 2 numbers are multiplied to give 40 and I had to give negative 13. Well, that's a negative 8 and negative 5. And when I solve, I'm now going to have a therefore x equals 8 solution from the first factor or 5 from the second. Hey, I actually get a little confirmation. There was the one root that the problem told me it had. I now found out the other root, and I'm just going to shrink that down a little more. Therefore, the other root is 8. There we go. Okay, there is one possible solution to that problem. And it really just started with find k. So let's sub in the root, solve for k. Now that I have that, I know the missing value, finish off the problem. Okay. What if I wanted to tackle a different solution though? I'm just going to put down the word or. What if my focus was on the other root? What if that became my focus? Well, what could I do to solve the problem? Okay, I'm just going to copy out in orange again the original equation, just so we can have a visual, just so it's a little easier for us to see. If I know my equation takes that form, but I know what I see boxed in blue, one root is 5, then I could do like what we just did in problem 2. I could work backwards. If one of my roots is 5, then it must have come from a factor of x minus 5. Like I'm going to go backwards and build the factor. That's just like we did in problem 2. We just didn't really talk about it that way. Well, now what I could do is I could use inspection to figure out what the other factor was. Okay, pretty quickly I should be good to be able to get an x there. The reason I can get an x is because I know x times something has to get me back to an x squared. Okay, I know what was missing was x. Let me get rid of that green. But now, when I look at my constant, a negative 5 times something has to get me back to a positive 40. Okay, I can just play through inspection. Negative 5 times what gets me to positive 40? That's a negative 8. There's my negative times a negative, gets me my positive. 5 times 8 gets me my 40. And if I come up with that, then I know pretty quickly that I get one of my roots, which was 5. That confirms it in the problem. Or 8, I just found my other root. Okay, what I haven't done yet is found my k. But you'll notice that's actually pretty quick. If I took my equation and I just expanded it, minus 8 minus 5 is a minus 13. I get a little confirmation on my first and last terms. Those match with the equation. And if the equation says my k value is the coefficient on x, then there is my coefficient on x. I could now say, and therefore, my k value is negative 13. Okay, you'll notice, if you take a look at both of those solutions, they're just backwards. My blue solution was if I focused in on the root being 5, and so I wanted to find k. My other solution was me knowing that the root is 5, but I want to find the other root first. In my blue solution, once I had k, I was able to factor. In my gold solution, once I had the other root, the other factor, then I was just able to go through and expand to find my k. Same process, 2 different directions. 2 different ways to solve that problem. I love that problem. That's a great problem. Okay, your job is to jump in and get some practice. And if you notice, all of those questions where we had to expand some brackets, collect like terms, then solve the quadratic equation, I would argue to you that if you were good working through those, then that takes care of everything from yesterday, from last time. At the end today, we threw in some quirkier problems, being able to work in both directions. Make sure we get some practice with those problems as well. Okay, your job, get lots of practice. Jump in. Good luck.